Hello all, welcome to part 10 of the Assembly Language Primer for Hackers video series. In this video, we will look at how to write functions in assembly language. So the way to define a function in assembly language with the gas compiler is using the type directive and then going ahead and saying that it is of type add function. And in the middle you have your function name, which is my function as an example. So once this directive has actually been given to the assembler, you can go ahead and define the my function label anywhere in your code and then have those lines of code snippets. And then finally, once the function is done, you need to compulsorily have a ret statement at the end of the function. So this is synonymous to the return statement which you would write in a C program. Finally, when you want to go ahead and call the function, you go ahead and use the call my function instruction. So very simple way to define the function. Now I guess you must be curious, how does one go ahead and pass arguments to a function in assembly? So the way to do that, you actually have various possibilities. So you could either use registers in which you could load the arguments before calling the function. You could use global memory locations, where probably you can go ahead and define a piece of memory in the .bss segment, or in the data segment, which you could go ahead later on and pass as argument. And then finally, you can pass arguments over the stack. As far as returning values is concerned, once again you can return the values in the registers or in global memory locations. So now let's look at a very simple example of how to write a function which is going to print a string onto the stdout. In this we will look at two variations of the program, one in which registers are used to pass arguments and the other in which global memory locations are used. In the next video, we will look at a more detailed example of how to use the stack in order to pass arguments to the function. Well, so let's move on to our example. Now, this is the function. First program we look at is function.s. In the .data section, I have defined two strings, hello world and hello function. In the text section, which is where the executable code should be, I've gone ahead and defined a function called my function. First, use the .type directive and then went ahead with the definition of the function. Now, exactly what does this function my function do? If you remember the hello world string printing video, we basically called the write syscall, and what we did was first we loaded the EAX register with the syscall number for write, which is 4. Then we went ahead and loaded the descriptor to which the output of the write syscall should be written to. In this case we said stdout and hence loaded 1 into EBX. Now then, if you remember, the third thing we needed to do is load the pointer to the string which needs to be printed onto the ECX register, right? This was done using the LEA set of instruction, which was load effective address. Then finally, the length of the string needed to be loaded into the EDX register. And once that was done, we went ahead and called the interrupt to go ahead and write that string onto stdout. So in this example, we have split up that functionality into two parts. Now, what is the variable part? If you look at it, the variable part is actually loading the string pointer into ECX and then loading the string length into EDX. The other operations such as loading 4 into EAX, which is the syscall number, or loading the stdout descriptor into EBX and then calling the interrupt, is something which gets repeated over and over again. So what we've done is isolated the functionality which needs to be done over and over again into the myFunction function. So this is where we've just had three statements in the myFunction function, and that is actually moving the value 4 into EAX, moving the value 1 into EBX, and then calling the interrupt. Therefore, what we need to do is, before calling myFunction, we need to load ECX and EDX with the string pointer and the string length. So now if you look at the start routine, this is exactly what we've done. First, you want to print the hello world string, and for that we've loaded the hello world string pointer into the ECX register. Then we move the value 14, which is the string length of hello world, into EDX, and then we call the myFunction function. So when this happens, immediately transfer goes here and these lines are executed, right? So it is actually irrelevant which registers are loaded when, and hence we can load the string pointer and the string length before we load the other registers. Similarly, we go ahead and print hello function by first loading the hello function string pointer into ECX, then loading the string length into EDX, and then calling myFunction. Finally, when these two print statements are done, we go ahead and exit the program. So let's go ahead, assemble this program. Let's link it. Now let's go ahead and run it. So as expected, first the hello world string was printed and then the hello function string was printed. So very simple. I think, in this case we don't even need to dig into much more of the functionality. I leave it as an exercise to you to go ahead and probably load the executable into GDB and actually see what is happening. So now let's look at a slightly more complicated example of passing arguments to functions using global memory locations. So in the previous example, we had to go ahead and load the registers before we actually called the function. This was painful. Probably if there could be some global location where always the string pointer and the string length would have been available, then myFunction would simply load it from there into the appropriate registers and execute the write syscall. So that is exactly what we aim to do in this specific program. So in the .data section, we have two strings, the hello world string and the hello function string. In the BSS segment, we go ahead and define two memory sections of size 4 bytes, the first being the string pointer and the second being the string length. So these are the two locations where we'll be storing the string pointer and the string length for both the hello world and hello function strings. Now let's go down. We've defined the myFunction, and in the myFunction label we go ahead and define the code for printing using the write syscall. So we are all familiar, load 4 into EAX is the syscall number, load 1 into EBX because we want to print into std out, and then load the string pointer into ECX, and then load the string length into EDX, then go ahead and issue the interrupt, and then finally return. So in the start routine, what is it that we exactly do? We go ahead and move the string pointer pointing to the hello world string into the string pointer memory location, right? And if you're familiar, in the moving data video, we looked at how we can load the pointer to any variable or any memory location which we define into another memory location, right? And similarly, we go ahead and load the value 14, which is the string length of the hello world string, into string length, and then we call the my function. This is exactly what we do for the hello function as well. Then finally we exit the program. So let's assemble this program and look at how this works. Now let's link it. Then let's go ahead and run it. So if you notice, exact same thing happens. Hello world and hello function gets printed. So let's go ahead and load up the function2 program in GDB. So let's list the program, and probably we should go ahead and place a breakpoint here to see what is happening. Let's run the program. We've hit the breakpoint, and this is the place where the location of the hello world string is going to be stored into the string pointer. So before that, let's actually look at exactly what is there in the string pointer currently. So we notice right now, as expected, there is nothing there in the string pointer location, and similarly there is nothing in the string length location. Now let's go ahead and print the memory location of the hello world string. So this is the memory location, and now as expected, once this statement is executed, this memory location should be stored inside the string pointer. So let's step through it, and now let's look at the string pointer again. So as expected, the memory location for the hello world string has been stored into the string pointer. Similarly, if we step to the next instruction, the string length has now been stored into the string length memory location. So you can actually go ahead and view this in decimal as well. And this is exactly 14, which, if you remember looking at the code, was the length of the string which we wanted to load. Now the next step is actually going to be calling my function. So let's actually look at where my function is defined. Let's disassemble. So this is the location where control should be transferred now. So let's step through it. And if you notice, right now transfer is going to get to the beginning of the my function. So we can actually even verify this by printing the EIP register. So this memory location is exactly what the EIP is pointing to right now. Right. So if we continue, we go ahead and print both the strings. So very simple demo in which we found how one can pass arguments both via registers as well as via memory locations. So I would encourage you to try out this example yourself by writing your own simple functions. In the next video, we will try and understand the stack in more detail and see how it can be used to pass arguments to functions. Well, that's all for this video. Hope you liked it. Would be really happy if you can leave behind some comments, whether you like the video, what more you need, etc. That's all. Thank you very much.